Hello friends, my name is Malik and welcome to my YouTube channel. In this video, we will migrate a running MongoDB database from on-perm to Kubernetes cluster with zero downtime. We will also make it production ready and automated backup to MinIO, a self-hosted S3 compatible object store. Everything will be done without Helm, so you see every detail clearly. Let's dive in. Here is the project we are going to work on that today. Migrate MongoDB to Kubernetes with automated backup. Here is the summary of this project. I was checking Upwork website and I saw this freelancer job, a company seeking a skilled DevOps engineer to help them migrate MongoDB to Kubernetes with automated backups, deploy MongoDB as a Statefulset or via Helm chart on existing Kubernetes cluster. Also, they need configure persistent storage, persistent volume and persistent volume claim, and also set up network access restriction and secrets management. Also, they need implement automated scheduled backup with retention policy. So, in this video, we are going to take care of these 4 steps. At first, we need to simulate a real-world setup because we need to have a MongoDB cluster, and after that, we can migrate that to Kubernetes cluster. After we prepare this MongoDB, we will go and deploy MongoDB on Kubernetes using a Statefulset and persistent storage. After everything be ready, we will migrate existing data from the MongoDB instance to Kubernetes cluster. And at the end, we will set up automated version backup. Let's start. Before I start, let's familiar with some terminology. Replica set, a group of MongoDB servers that work together to provide high availability and redundancy. In simple terms, a replica set is like a team of MongoDB servers where one is primary and we can say leader of the team and the rest are secondaries. These secondaries will copy data from the primary one. So, primary one accept all writes and reads, but the secondary one copies data from the primary and they are read-only. So, to simulate existing MongoDB cluster, I'm going to use Docker. As you see, by this command, we can create a MongoDB container. But as we spoke some second earlier, we need a replica set. We need a cluster of MongoDB database. Why? Normally, each company that are using MongoDB database, their architecture is based on replica set. If one of them is going down, the others will continue and take care the responsibility. So, by adding this flag --repl_set and also give it a name, we will change the container to replica set, and if we want, we can add another machine to this cluster. So this command tell MongoDB to start as part of replica set name rs0. Now MongoDB only listen to this address 127.0.0.1 as it is the local host and make it inaccessible from the other container or Kubernetes pods. So we must bind MongoDB to all network interfaces with this flag --bind _IP _all. So by this command we will bring up a MongoDB as part of a replica set called rs0 and also will listen to all IP addresses that are binding to all network interfaces. So finally, before bring up the container, we need to access it from a reachable network resolvable address by adding --add host and also the Docker LAN gateway IP. If you run the command IP address and look for Docker interface, it will show you which CIDR block is using for Docker interface. So you will select the gateway address as I did here on my local machine and will add it here. So this is the final command that we are going to run and bring up a MongoDB to simulate an existing MongoDB server. Let's go into terminal and bring up the Docker one. Here is the terminal and let's run this command. As you see, Docker run in detach mode and the name of that is Mongo01. Also expose port 27017 from my machine to the Docker one, and also I'm using this path as a storage to mount on MongoDB. Also, as you see, --add host and this IP address, this is the gateway IP of Docker interface on my machine, and also with --replica set, we will tell this Docker to bring up as a cluster and also the other flags. Also the last flag that I didn't speak about it, --port, we tell MongoDB listening to this port. So let's click enter and check Docker ps grep mongo01, and as you see it's in running status. So let's run Docker exec-it, the name of the Docker container, and run the command mongo sh. As you see, we are connected to MongoDB shell. With this prompt, it shows we are using test database. If I do show dbs, you see node is not in primary or recovering state. It means still we have to do one step more before let us using database. So we have to initiate our server. In Google, if I do mongo initiate replica set, from the result click on the first one, and here is the official document of MongoDB. If I going down, here you see a command to initiate your MongoDB. Just I copy this one in a text file to edit, and then we can use it in MongoDB server. Let's remove this one. We don't need it here at the moment. What's the ID for this replica set? If we back to terminal, you see we were using rs0. So here change it to rs0, and for the members at the moment just we have one machine. What's the IP address of that? So here we have to add my Docker IP address. Let's back to terminal, exit from here, Docker, inspect the Docker name. You see the IP address is 172.17.02. Copy this one, back to node, paste it here. Copy this one, back to terminal, connect to Docker machine again, and run it here. Just paste and enter. You see the prompt change. If I do another enter, you see it is belong to replica set 0, and it is at the moment the primary one. If we add another machine to this cluster, automatically they will go to secondary machine. So at the moment we have a cluster with one server, and this one server is the primary one. Let's clear a screen. Now if I type rs.status here, it will give you all details about your cluster. As you see, members, this is the IP address of this machine, this Docker machine, and the state of that is primary. If we add another machine, here you will see it as the secondary one. Let's clear a screen and let's type show dbs. Here you can see the default databases on this machine. Maybe this question comes to your mind, why we cannot see the test one in the list, because at the moment we don't have any data in this database, so cannot see in this list. Let's clear a screen. In next step, we need dataset. So we need to import data here, and then our database look like the real one, and then we will see how we can migrate that to Kubernetes cluster. Let's going and copy a data set on this MongoDB server. I have some data set with the JSON extension here. Let's copy one of these data set to our MongoDB. For example, this one, students.json. By using this command, docker cp students.json, the name of dataset, and to this container mongo01, to which folder, to /data. Let's enter. Let's connect to Docker container. Just type ls/data. Here you see the data set that we did copy here. By this command, mongo import, give it a database name, every name you want. Here I selected my DB and a collection name. For example, here I selected students, and what's the name of the file? student.json. It is located in /data. Enter. You see 200 documents imported successfully. If I run mongo sh connect to shell of Mongo, and just type show dbs. Here is the database, and let's use this database name, switch to MyDB, and type show collection. Here is the collection name If I type db collection name and find enter, it will show the data in your database. Now our database is ready, and in next steps you will see how we can migrate this database to Kubernetes cluster. Stay tuned. Applications like databases should be deployed as a stateful set. A stateful set runs a group of pods that need persistent volume or unique network identification. Based on a stateful configuration, each pod should have a dedicated storage. As you see here, each one has a separate storage. Also, in database cluster architecture, only one of them can use as the writing one, and the others working as the reading. Just in Google type Kubernetes Statefulset, and from the result click on this one and go to the official document on Kubernetes, and here you see a lot of information about a Statefulset. If we scroll down, here is an example that we can use in our scenario. Based on our discussion, I have prepared some manifest to deploy MongoDB on Kubernetes cluster. Here you see the list of the file I have created. At first, let's have a look to MongoDB Statefulset configuration. Cat this file. As we were discussed, you see here, we will go and create 3 replicas from this image, MongoDB version 6. Also, you can select the other version as you want, like the latest one. And also, you see here for the volume claim, it will go and create separate persistent volume for each pod. Let's clear a screen. As I told you, I'm using my personal computer, so we cannot use dynamic storage classes or dynamic persistent volumes. So to simulate that, I will go and create 3 persistent volumes separately. Cat pv0.yaml. Look here, I will go and create 2 gigs storage as persistent volume 0, and the same for pv1 and pv2. Let's create persistent volume. kubectl apply -f pv0, and also for other one and pv2. kubectl get pv. Look here, 3 persistent volume created and they are available. So let's go and create MongoDB Statefulset kubectl apply -f and MongoDB YAML. If do kubectl get pods, look here, 3 pods created. kubectl get a Statefulset. Let's clear a screen and kubectl apply -f svc, and we are going to deploy service for this Statefulset. kubectl get svc, as you see, headless service created. kubectl describe svc and the name of the headless service. Look here in endpoints, 3 hosts binded here, so kubectl get pods -o wide. As you see, the IPs here and compare with them in service. It seems all good with them. Let's connect to the one of the pods and check if everything going well. kubectl exec-it, this one, mongo sh. Successfully we are connected to the one of the pods. as you see, still there is no initiate, as we see this pod as a standalone server. Let's exit from here and connect to the number 1, and the same here, and number 2 also the same here. So at the moment we have 3 separate MongoDB server. If I run replica set initiate on one of them, all of them will be members of one cluster. One of them will be primary and the 2 others will be as secondary. If we don't need any migration and want to use this MongoDB cluster as a new database, the next step is to initiate the cluster by this command. But here our scenario is to transfer current live database to Kubernetes 1. In this case, we hold the initiate and leave the paths as is. In next step, we need to have access this Kubernetes cluster through Docker 1. Stay tuned. Exit from this cluster, clear screen, kubectl get paths-o wide. Let's copy one of these IPs and going to Docker 1 and ping it. Docker exec-it mongo 01. Let's connect to Docker 1 and from here ping one of these IP address. Okay, so here we don't have ping tools. Let's install it. apt get update, apt get install -y IP utils -ping. Okay, ping installed. Let's ping it. As you see, we can ping the Kubernetes host from this Docker container. Now let's using the DNS name. Ping MongoDB-demo-0, it's the pod name. MongoDB-SVC, this is the service name, namespace, and this one, .svc.cluster.local. If I ping it, this address not resolved. As we don't have DNS server here, let's add them manually. Vim etc hosts. Let's install Vim apt get install vim-y. Clear screen and let's edit this one. Open a line here and add the Kubernetes host here. If you want to be sure, let's split this terminal and just connect and just type kubectl get paths-o wide. Look the IPs and the same we did here. Let's save it. Let's run the ping again. Look here. So at the moment we can ping by DNS name. So at the moment we have access through Kubernetes 1 by DNS name. Let's exit from this one and just type mongo sh connect to MongoDB shell. Now we want to start migration. The first step is to add the Kubernetes host here as a member for Docker 1. As you see, the Docker 1 is the primary. So when we add Kubernetes 1 here, they will be as secondary. When we add them to the cluster, automatically the database will start to copy on the members one by one. Let's start. I have a script here, and this script will go and connect to Docker database and retrieve data from that. Let's run it. As you see, it connects to Docker database and retrieve data from it. Let's stop it and cat script. As you see, here is the Docker address 172.17.02. Let's clear a screen. Let's back to Docker MongoDB and add the Kubernetes host as secondary or follower. By this command rs.add, and inside the parentheses we add the DNS name of the Kubernetes. For example, I'm adding the first pod of MongoDB on Kubernetes cluster here. The name of that is this one. Let's exit from this one. kubectl get pods mongodb-demo-0. Let's enter. You see, okay, successfully added MongoDB demo 0 to Docker cluster. Here, if I type rs.status, enter. Look here, the members, the Docker one as the primary. The second one should be as secondary, but at the moment is not reachable or healthy. So we will fix this one. Let's exit from here. Vim etc hosts MongoDB demo-0. Let's ping MongoDB-demo, this one. Ping this address. It is pingable here. Let's clear a screen. Let's remove this one and add the same host that we are using in etc hosts. Okay, status. Here you see, in this time there is no error here, but we have this one with the error. Yes, you see, the service address we used here was in mistakes, so we have to remove this one. Just back here and using remove. Let's clear a screen and check a status. Look here, this one is the primary and this one is the secondary one. So let's run this one again and add another pod and also this one. Clear a screen and just run rs.status. Look here, the Docker one as the primary, MongoDB demo 0 secondary, this demo 1 and demo 2 are as the secondary. So let's connect to one of the pods on Kubernetes cluster. As you see, the prompt change and automatically add as a member of a cluster. Now we are in such situation. We have one MongoDB server on Docker as a on-perm or existing database that as the primary or the master one, and we can write and read on it by an application, and or Kubernetes pods as the secondaries. At the moment we have 3 pods and they are playing as the secondary 1, secondary 2 and secondary 3. So we have a MongoDB cluster with 4 servers, 1 in on-perm and 3 on Kubernetes. So As soon as we add the Kubernetes to this cluster, the data start clone from the primary to the secondary one. And after the clone done, they will start to be synced together. As soon as all data done with the secondary one, the secondary two will start clone the data from the secondary one. And after everything be done, the secondary two will be synced with the primary or master one. And also the same thing will happen on secondary tree, and it will clone data from the secondary two and finally will be synced with the master one. So let's go into terminal and see if the data cloned and be synced on each of them one by one. In the right side, I am connected to the primary one as it is Docker one on-perm, and in the left side, I am connected to the first pod as the secondary one. Now the left side should be in sync with the right one. If here I type show collections and the same on the master one, and type db.students.find on both of them, look at the end, ID 29 on both of them, the same name. Let's clear a screen on both of them, and just using this command here in the output, you will see the number of documents on database, the number of records. Here we have 200 records on both of them. So the primary and the secondary one are in the same status. Let's exit from primary one and connect to demo01, the second pod. Use MyDB, show DBS, and show collection. Also, let's run this command here. Look here, the same on secondary two. Let's exit from here and connect to the last pod, number 2, and run, and just let's use MyDB and run this command, and look here, 200 documents. So all 3 pods on Kubernetes as the secondary pods are in the same status like the primary one. Just connect to the test machine to run a script, vim script. In a script, as you see at the moment, we are connected where? Only to the Docker one. So let's add the Kubernetes address to this variable to work as a failover. For example, if the Docker one is going down, the others take care of that. The others will be responsible for the request. Just copy this one to the new line, disable this one, and let's remove this one from here to here and add this one here. As you see, instead of using only the Docker one here, I use all of the members, the Docker one as the primary, and the demo0, demo1, and demo2 as the secondary ones. So let's exit from this one and run it. You see, it still is working and read and write the data from the Docker one. Let's stop here, back to here to see in live. Clear a screen by this command, rs.stepdone. If I run it on the Docker one, the existing database on Docker will go down. Let's run it. A script still is ongoing and retrieve data from the data set, but from the left, if I run rs.status, look here, this one changed to the secondary, and one of the Kubernetes one got the primary responsibility. So on the Kubernetes, at the moment, the first one is the primary, the others are secondary, and also the Docker one works as secondary. Now it's safe to remove the Docker one from the cluster. So now it's time to remove the Docker one. Let's clear a screen. Just type rs.remove and 27017. Let's run it. New config is rejected because this responsibility only have to do by writable primary. Only the primary one can do it. So let's exit from here and connect to MongoDB demo 0 that is a primary one. Let's run it. rs.status. Look here, the primary is this one. So at the moment we are connected to this one, and let's run this command. As you see, the Docker host removed successfully, and let's confirm that members MongoDB demo 0 is the primary and demo 1 as a secondary. Also the demo 2 is secondary, and you don't see anything about the current existing one on Docker, but still the scripts is working and retrieve data from the data set, but the data set is located on Kubernetes. As you saw here, we did migrate data from the existing Docker or on-premise one to the Kubernetes one without any downtime. It means zero downtime. And after that, we successfully remove and shut down the existing one. Stay tuned for the next step. To set up manually or automated backups, we need an storage. As you see in this diagram, we can use cloud storage like S3 on Amazon and record our backups. But if you don't have access to S3 at the moment, we can use replacement storage is like AWS S3 called MinIO. MinIO is a high performance distributed object storage system, and it is Amazon S3 compatible. Also, it can be deployed anywhere. Also, we can bring up this MinIO on Kubernetes cluster. Today, I'm going to bring it up on our Kubernetes cluster. So to deploy it, like other resources on Kubernetes, we need persistent volume. And here we are going to use persistent volume. And here I did prepare a PV for this MinIO cat and PV-MinIO. Let's clear a screen and run it again. As you see here, I have created this folder in this path to record backup data here. I'm using this storage class name called MinIO. Also, at the moment, I'm using 5 gigs for this persistent volume. Clear screen. Also, I have created a PVC service and deployment for MinIO. Let's open it. Here is the persistent volume claim that will go and take storage from persistent volume. Look here, the same storage class I'm using here, and also I'm using a deployment. I take this template from MinIO official website. Here using 2 ports, port 9090 and port 9000. 9000 is for using API connection to MinIO, and 9090 is for browsing on your web browser. And also here, as you see, we are using, also I did hard code the username and password to access web UI for MinIO here, and also this node port service to access web UI, and the same for API. Let's go in and deploy them. Clear screen. At first, let's start with deploying PV for MinIO. kubectl apply -f and PV created. Just type kubectl get PV. A new PV created here, and it is in available status. And also let's deploy service, deployment, and PVC. kubectl apply -f and this one. PVC created and bonded to this one, you see, to MinIO PVC. And let's check service. Look here, 2 service node ports, one port 9090 and the other one is 9000. Let's clear a screen and get deployment and pod. So to access web UI, we can use this port. To access web UI, as we are using node port, let's take this one and kubectl get nodes-oy with this IP address. Let's go into browser, open a new tab, and here just type the IP address, this port. As we did hardcode username and password directly in deployment, didn't ask for username and password, and directly went inside MinIO storage. Here is the web UI for MinIO. Just we need to create a bucket. Let's define it demo and create bucket. So our bucket is ready, and we need to define it in a cron job to take a backup from MongoDB and record it here. So we need a cron job. Clear screen. I have prepared a cron job for this one. Here is the cron job. By this cron job, each 6 hours will go and take a backup from the data set in MongoDB to MinIO store. Here is the cron job that I have created, and it is scheduled for each 6 hours. It means in each 6 hours it will go and get backup from MongoDB. As you see here, I'm using Mongo image. As you see, this cron job is scheduled for each 6 hours. It means each 6 hours will go and take backup from the database on Mongo server. Also here, as you see, I'm using this image, Mongo version 6. Also, you can use every version you want. Then it will bring up a pod and install curl, unzip, and MC on it. What is MC? MC is the MinIO client, a command line tool designed to interact with MinIO object storage servers and other Amazon S3 compatible cloud storage services. It means in each cloud that we have S3 compatible storage, we can use this MC to record backup on that storage. And also for MinIO username and password, I'm using this secret file. So let's go in and deploy this manifest. And also we need to deploy the cron job. The cron job will go and automatically run each 6 hours. kubectl apply -f and cron job. kubectl get cron job and also secret one. Here to verify cron job, we can define a job to trigger that and see if everything is working good or no. Let's do it. By running this command, it will go and create a job from this cron job and run it manually. Let's run it. kubectl get job. Still not completed. kubectl get pods. Status completed. And job also completed. Let's go into MinIO interface and refresh here. Here is the date of today. If I click on it, this is our database on MongoDB and this is the name of collection, student. It seems all good for this tutorial. I hope you like it. If you like it, please don't forget to add your feedback in the comment section. Thank you so much. See you in another video.